Okay, next up we will be figuring out what the integrated rate law is. And it's just an equation that's typically used in chemistry, and it just relates the concentration of reactants or products, so just the species that you're working with in chemistry, to time. And so it actually writes the concentration in a manner that is proportional to time. And so you can rewrite that as A as a function of t, basically. And the integrated rate law itself states that ln A is equal to ln A initially minus kt, right? So this would be A represents the concentration at whatever time, because it doesn't have a subscript. And A with the subscript of O is the concentration initially. So at t is equal to 0. And so if we just rearrange this equation, we can get that kt is equal to ln AO minus ln A. And then we can use the logarithm rule in order to recognize that log base A of m over n is equal to the log base A of m minus log base A of n. These two both have the same base of e, so we can apply this. And we get that kt is equal to the ln of my initial concentration over the concentration at whatever time. And then we can solve for this by moving over the base, which is another logarithmic property. And that just states that if you write log A of B is equal to C, you can rewrite that in exponential form as A to the power of C is equal to B. So we're just going to apply this here, and just remember that ln can be written in the form of log base E. And then we just rewrite what was in our brackets. And then we're just going to move the base on over. So it will become E raised to KT is equal to initial concentration over my final concentration. You can alternatively decide to rearrange the equation differently at the beginning and leave it in the form of negative kt is equal to ln of A minus ln of A initially. Yep. And so again, this would become ln concentration of A over initial concentration of A. If you just use the same properties we used before, which would become e to the power of negative kt is equal to A over initial concentration. So any of these two can be used, and they're quite useful in your calculations when you're performing in chemistry, for example, in labs.